Greetings, dear friends. Welcome back to my YouTube channel. As you know, we are in the module called Abaqus for Beginners, and here we are with the last tutorial of this module. And here in today's lecture or today's tutorial, we are going to model and analyze reinforced concrete column of the dimensions as shown on the screen. Reinforcement detailing is also given, and we're going to analyze this column for the loading of 100 kilonewton, as you can see here, actual load of 100 kilonewton. The idea here is not the analysis or the results of the column. We are not concerned about the ins and outs of the analysis of the column. But idea again, since this is again video that belongs to the module called for video for beginners or Abaqus for beginners. So we are concerned about how different tools can be used to create different types of geometries. Since here we are now going to create three different parts, one part for concrete, another for longitudinal steel, another for transverse steel or the stirrups. So we'll be creating three different parts, and then how can we, how we are able to assemble them in the assembly module, how to use interaction between concrete and steel. So basically the idea is about how to work with the tools, how to get used to these tools, and how to use interaction, how to visualize results. And I think this video will definitely going to, you know, uh, be kind of a finishing finishing video of this tutorial. This will definitely enhance uh, again the learning of the graphical user interface of Abaqus, and of course and get used with the tools of the software. So I think let's get started. So here the dimensions, as you can see, 400 by 400 mm cross sectional dimensions are there. 400, it's a square column with longitudinal steel of 16 mm dia, and we have a transverse stirrups of 8 mm dia. As you can see, we have to length of the column as 3 meters, and we have a cover of 50 mm. Spacing of these transverse ties is 100 mm, and grade of concrete we have to use as 30 megapascal. Similarly, yield strength of steel is given as 500 MPa megapascals, and actual load of 100 kilonewton. So uh, we'll be doing linear elastic analysis. So let's get started. So we have to create three parts for analyzing this RC beam or RC column rather. Let's create part 1. Let's name it as concrete column. We have to use extrusion. Okay, this is our canvas, drawing canvas. Here I will take a rectangle. I'll draw rectangle, then I'll go to the dimensions, add dimension. Between this point and this point I'll add dimensions, and this has to be 400 mm. I'm using mm as my units, and I have to be consistent with that. And this also has to be 400 since this is a square column. Here I'm done with my cross section of the column. Escape, say done. It asks for the depth. That means what is the dimension in the longitudinal direction, and it is 3 meter. That means 3000 mm. Here I go. So I created a concrete column part. Now let me go to the part, create part. It says part 2. The next part has to be longitudinal steel. So I can model them as solid, but let's model them as wires, one-dimensional those elements. Let me use wire. Continue. I'll draw a line of any dimension, I don't know. Then go to the dimension, add dimension. So what should be the dimension of this longitudinal steel? If I use a cover of let's say it's not, it's the edge, actually the edge distance, or let me say it's 50. It has to be 2900. 3000 is the total height, or yeah, height of the column, and I am modeling this reinforcement bar as 2900 mm. That means 50 mm cover at the bottom, 50 mm cover at the top. Okay, escape, done. Okay, I am done with the part 2 as well. Since I have not named it, I have named it's named as part 2. Let me rename this as, we can do it here in the tree module, here in the tree. So go to the rename, longitudinal steel. Right, now let's go to the part again, create part 3, stirrup. Again wire, I'll have to create a rectangle here. Now I'll have to make it, what should be the dimension of this stirrup? So this has to be, since cover is assumed to be as 50 mm on either side, 50 mm on right side, 50 mm on left side, so I'll have to deduct 100 mm from 400 mm, so this has to be 300. Now this dimension also has to be 300. Escape, done. Okay, I'm done with my third part as well. So in the parts we have concrete column, longitudinal steel, and stirrups. Single stirrup I have used. Now after creating parts, what is the next step is properties. So I have two different materials, right? First is concrete. Let me name this as concrete. Density, general density. Since I'm using mm, in the very first of the videos I have mentioned what is the unit system that we need to use. You can Google it. When we are using mm, what should be the units of density? It should be tons per mm cube. So it is 2400 kg per mm cube. So we have to use 2400 e power minus 12 to, when I'm converting this to tons per mm cube. Go to the elasticity, mechanical. I have to give my elastic properties to concrete. Elastic properties. What should be the Young's modulus? Grade of concrete of 30 MPa is given. So what should be the Young's modulus? That is, let's as per IS 456, it is 5000 square root of FCK MPa, right? So this has to be some 2700, approximately 27,000 rather. MPa is the Young's modulus for concrete. Poisson's ratio, let's assume as 0.2. So I'm done with the concrete. Now I have to create another material, steel. General, what should be the density? Density is 7800. We know it's kg per meter cube, but we have to use tons per mm cube. So I have to multiply this with the e power minus 12. Now mechanical, in the mechanical I have to give elastic properties as Young's modulus as 2 in 10 power 5, right, megapascal. Poisson's ratio, let's assume 0.3. So since we are going to do static analysis only, or linear elastic, what I've already mentioned, so we need not go with some plastic model or something like that. So here these are enough. But since grade of the steel is also mentioned, yield strength is mentioned as 500 MPa. So we can go to the plasticity, plastic, yield stress 500, plastic strain 0. That means up to its maximum yield stress this is going to develop is steel is going to develop is 500 MPa. and let's say okay. Now since I'm done with the part creation, properties I have already created, now I have to create sections. Create section. Let's concrete section. Concrete section, and section has to be homogeneous and solid because we have already created that as a 3D solid homogeneous part. Okay, this section, what material this section has to have? It has to have concrete. Okay, I need to create another section. That's for the longitudinal steel section. And since I did not create it as a solid homogeneous, I have created as a wire, so I need to go to beam. Let's go beam, beam, continue. I have to assign the cross section to this wire. I don't, till now I don't know what is the diameter of the bar, longitudinal bar. I have not assigned anything. Since here it is 16 mm, let's create a profile. It has to be circular. Okay, what is the radius? It has to be 8 since diameter is 16. Okay, what is the material that's going to be assigned to this longitudinal steel? Let's use 0.3. Okay, I'm not yet assigning the material or the section, I'm just creating the sections. I have to create another section. That's for the stirrups. Again, beam. Profile 1 is already created, but I need a different profile because its dimensions are different. It's 8 mm dia. Profile 2, circular, 4 mm radius. Okay, I need to assign profile 2 to this stirrup. What is the material? Again, steel. Poisson's ratio 0.3. Correct. Now I need to assign these sections that I've created here. If you see, I've created concrete section, steel section, and stirrups, right? So let me go to assign section. Assign section. This is the concrete column. Let me go to the assign section. Select the regions to be assigned as section. This is the region that I want my section to be assigned to. Here I will say done. It will ask which section do you want to assign to this concrete. Yes. Now it has turned blue. That means section with along with the material is assigned. Now go to the part 2 section. I want to select this. Done. What section do you want to assign to this? Longitudinal steel. Done. Go to the third part. Go to the assign section. Select this. Select this whole stirrup. Done. I want to assign this to the I want to assign stirrups to this section, to this. And of course here you can see here the material assigned to this section is steel. So I'm saying okay, done. Okay, I'm done with the part creation. Then I have created properties, created sections, and assigned those sections to 3 different parts. Then one more thing I'll need to do for this steel and stirrups, longitudinal steel and stirrups, is I have to assign beam orientation. Assign beam orientation. Select this. Done. I have assigned beam orientation to this. Go to the stirrups, beam orientation. I have to select this whole stirrup. Done. Okay, I'm done with part and the property. Now the major that I am really focusing on here is assembly. And here you will learn how to assemble different parts into, if I am going to create an assembly out of multiple parts, how to do that. Second, how can you rotate, how can you translate different instances or the parts or the elements here. How can you rotate, or how can you create multiple copies? Since I have just created a single stir up single longitudinal, that reinforcement bar, I'll need to have multiples of those. So how do I do that? You'll get to know here. So I'll need to go to assembly. These are my three parts that I want to assemble, right? To create a single monolithic reinforced column. So I have selected all the three. I'll say OK. So all the three, here is the reinforced, here is the concrete, here is the longitudinal beam, and I'm not able to see, here is my stirrup. Here is my stirrup. If suppose sometimes what happens is this stirrup would get embedded into this and I'm not able to visualize this. So what I'll do is let me remove this from the site. So how to do that? It's a temporary, I'm hiding this temporarily. Let's go remove cell. Which cell? This cell. Done. Now you can see longitudinal steel and stirrup is here. So let me, for some time, let me hide that solid concrete block. I'll create a cage first. Cage of this longitudinal and this stirrups. I'll need to create I'll be creating a cage and then I'll move that cage inside that hall, inside that solid concrete block. So here, they are in the same plane. So what shall I do is I'll have to rotate one of the two. Let me rotate this stirrup. How to do that? Go here, different tools are there. Rotate instance is there. Click on rotate instance. Go to this stirrup. Click on this. Done. It says define the axis of rotation. I need to rotate this in, if you see, XZ plane, in XZ plane about Y axis. So this is the axis, vertical axis is the axis that I need to rotate it about. So let me click on, first point is this, and the second point is the top point. The rotation angle is 90 degree. Okay, I just got rotated. Okay, here it is. Right, it's perfectly rotated. Now what I need to do is I'll move this bar to this point. Here is the translate instance. I need to translate this. Done. This is my first point of the translation and I want to move it to this point. Okay, yeah, done. Now I need to create multiple copies of this. Right, multiple copies of this. How many copies? It is like I need to create 1, 2, 3, 8. I need to create 8 bars. How do I do that? I can do it multiple ways, but let's do it this way. Let's go to the linear pattern. This will create multiple copies. I want a linear pattern. I want to create patterns of this. Done. Not in all the directions. I'll switch off one of the directions. I want to create multiple copies of this in a single direction only. So I need 3 in this direction, right? I'll say this is the direction. You need to click on here, this direction arrow. This is the direction. How many copies? I need 3. What should be the spacing between the 3? And the spacing, since the total is 300, is it 150? Yeah. So it's done. Now what I'll do is I'll select all the 3. I'll go linear pattern. These 3. Done. I'll switch off one. I'll say this is the direction now. I want to have a linear pattern in this direction. But what is the spacing? 300. You can see these 3 are here as well. Done. Correct. Now I need We need 3. Okay, now let me select this one. You can see here. I need one here at the center of this and one here. So what I'll do is I'll select one of, no, I'll go to the linear pattern. I'll select this. I'll say done. I'll switch off one. I'll say this is the direction, and 150 is the distance, but it's on the other side. So I can flip this. It's created one more instance at a distance of 150. Okay, now I can translate this one to the bottom. Translate, not the translate, but create linear pattern of this in downward direction. This is the direction at a distance of 300, but it's again in the reverse direction. So what I'll do is I'll flip. Right, okay, now I think I have created those 8 bars. 1 2 3 4 5 6 7 and 8. 3 at the bottom, 3 at the top, and 2 on either sides. So total 8 bars. Now what I'll need to do is I need to create multiples of this stirrup. How to do that? What is the spacing? If you see here, spacing of transverse ties is given as 100 mm. So we know the total length of this longitudinal bar is 3,900, right? Sorry, 2,900 mm. So if you divide 2,900 by 100, so you will need 29 spaces. That means 30 number of stirrups. What I'll do is I'll go to the linear pattern. I'll select this. I say done. I'll switch off one of the distances. I'll say this is the direction. I want this to be translated, or I want the copies in this direction, the longitudinal direction. How many copies? And at what distance? I want it at 100 mm distance. How many copies? 20, 30. 30. But it's on the other side. Flip. See? I'm able to create stirrups. 30 number of stirrups. Done. Okay, I'm successful in creating reinforcement cage that I was supposed to create. What I'll do now is I will, since I had removed for some time the concrete block, what I'll do is I'll replace all, means it will call all those things that are hidden. Here's the concrete block, but again I need to translate either the cage or the concrete block. It's easy to rotate this concrete block. I'll go to rotate instance, this about y-axis. This is the first point, this is the vertical second point. Rotate it by 90. Okay, done. Now what I can do is I can translate this whole reinforcement cage. Done. I will copy the bottom of this to the bottom of this, right? Okay, but it's not yet aligned properly. If you can see, if you want to see a hidden, not the hidden, rather wireframe of this model, it's this. It's here. You can see the wireframe. It's not properly oriented. The reinforcement is not properly placed. There's no proper cover. If go to the cross section, if you can, here, the reinforcement is placed like this. So what I'll need to do is I'll need to again translate this whole reinforcement cage by some amount so that I get a proper placement of this reinforcement. So I'll go to translate, but before that I need to hide. So let me first decide which direction I'm going to translate this in. Reinforcement minus z. I need to translate this by 50 mm in minus z and minus a plus y. What I'll do is go to translate, rather first hide this, remove selected, select, this is the concrete block, done, this has been removed. Now translate this, whole reinforcement cage has been selected, if you see. Yeah, so I'm in this view. What I'll do is done. Start point should be the same. I want to change my end point. X has to be the same, y has to be 50. I want to translate this by 50 mm and z as minus 50, right? Okay, now if you see, where is it? This is the view. I think it's the proper placement. See xy. I think I need to also change the x as well. First let me say, okay, I'm done with this. Now I need to move this in x direction as well. I need to go to translate, select the whole reinforcement, done. Start point has to be the same and x has to be 50. 50 at the top and 50 at the bottom. We had decided the cover. 50, done. Okay, yeah, it's pretty much fine. Okay, it's properly placed in the longitudinal direction. Let me see, this is the back view, front view, and this is the cross-sectional view, and I'm done. I'm done. Now I can call all the parts. Yeah, and I can go to the solid view, shaded view. Here is the shaded view, other views. Okay, so I'm done with the assembly. I hope you will like these tools. These are very useful in when you're assembling different parts in the assembly module. Now the next step is create the step. What type of analysis do you want to do? Let's go to create step. Static general, yeah. Continue. Incrementation, let's use 0.001. This is the initial time step. It doesn't matter because this is static analysis. Done. In the field output is the result that you want. Here, edit. The result is given stresses, strains, displacement, forces, content. I think it's enough. But what I want is, I want my output at every 0.1 seconds. Total time of analysis is 1 second, so I'll have 10 frames. Right, done. In the history output as well, I'll put as 0.1. Correct? Sorry, in the x units of time, and it's to be 0.1. X units of time. Okay, done. Now the next part is interaction. Very important here, because we have to create an interaction between the reinforcement and the concrete. So what I'll do is, I'll first hide this, that is concrete. Concrete. I'll hide this, done. Yeah. Now what I'll need to do is, I'll go to the create constraint. In create constraint, there's an option called embedded region. This is the interaction that we need to define for reinforcement and concrete. So select the embedded region. It says which of the parts you want to embed. I want to embed this reinforcement cage. Done. Okay, what is the host region? Host region is my concrete. So what I can do is here, invert display. That means it will hide the one that's getting displayed and it will display the one that's hidden. And what's hidden is this. Select a region. This is the region. Done. Yeah, by default. Okay. Okay, I have defined interaction between steel and concrete. Now let's go to the loading. Let's go to the loading. Let's first fix one of the ends. Boundary conditions. Create boundary condition. Symmetry. Continue. Let me fix the bottom. Let's assume this is the bottom. Done. Encaster. Encaster is fixed boundary condition. Okay. Now I have fixed the bottom. Let's assume this as a bottom and this as a top. Now at the top, I need to apply a load of 100 kilonewton. So how do I do that? As a point load. Let me define a reference point at the top. Reference point at the center of this top face. So how do I do that? If I go to the tools, then reference point, it says, okay, let me see which of the points is a reference point. You want to make it as a reference point. Since I want a reference point at the center and I do not have a point there, so I cannot define it. So what I need to do is I need to create a point at the center first. Some point, a node. How to do that? Let me go. Here are the options. If you see XYZ, there are options like create datum point. Here is a datum point midway between 2 points. I'll say okay. I need to create a point between 2 points. One is this point, another is this point, and automatically a point at the center is created. Now I will go to the tools, reference point. It says select the point to act as a reference point. Okay, this is the point that acts as a reference point, and a reference point is created there, right? Now what I need to do is I need to couple this point to this surface. So if I apply a point load at its reference point, that automatically gets distributed to the surface at the top. I'll need to go to the interaction again. Again, constraint. Coupling is an option. Coupling. Continue. Select the control point. This reference point is the control point. Done. Select the region with which this has to be coupled. This top surface is the region that I need to couple. Done. Done. Kinematic coupling is created at the top. Now the next step is the loading. I need to go to the load manager, create here, or directly go to here. Concentrated force, continue. This is the point. Minus y, so I need to create a minus 100. Minus is downward. 100,000. That means I'm in newtons. So if you go back to the unit system that I'm using, you'll get to know I'm using newtons. So since this is 100 kilonewton, so I need to do like this. I need to do like this. Continue. Okay, I'm able to create different views. You can see. Oh, actually I've done it wrongly here, so I'll need to put it in minus x actually, rather plus x. I'll need to go to load again, edit this load, put it 0 here, put 100,000 here. Yeah, now it's in correct direction. You can see, or you can, in wireframe system, you will be able to visualize it. Here it is. Your column is ready. Now the next part. I'm done with loading as well. Now the meshing. I need to mesh it part by part. Let me mesh it, mesh concrete column. What should be the mesh size? Let me say that 50 mm is the mesh size for column. Done. Go to part mesh. I've already discussed these things and I'm repeating them, so that's why I'm moving a bit faster. Now concrete column is meshed. Mesh steel column. Go directly, no matter. Okay, let's assume 100 mm mesh size for this. Apply. Okay. Mesh. Yes. Stir up. Let's assume 30 mm. Okay, fine. Mesh. Yes, I'm done with the meshing as well, and I think I'm ready with my job. I'll create a job column, rather RC column. Continue. Okay, RC column is a job is created. Now I need to submit the job. Let's say if any error is there or I need to change anything. We have done pretty much like things. The things that I have done are fine only. So let's see if there are any errors or not. Here we can monitor the progress. By the time, okay, it has started running. It has. It shouldn't take much of a time because this is just a linear elastic analysis. So uh, I hope this will be, this will finish soon, and we shall get some results to view. Let's for some time. Let's refresh our system. Yeah, it has started running, and I hope we won't be getting any errors now, and we shall be getting our results soon. Yeah, it has started running. So total number of output, those increments we have requested is 10. So already 4 are completed. 8, and I believe we are almost done. I think we have requested more. 100. Okay. Total time is 1 second. So actually we have requested 100 increments or 100 frames. It might take some more time then. Here if you see in the step, what we had done was field output, rather in the step initial we had used 0.001. One is that thing. Second is in the history output. We are all okay. It is in the steps that we had, the increment that we had used has really created this problem. Now, because initially we wanted this to use as 0.001, it won't be going to 100. It will start. It will finish soon. 0.1 is what we had asked, but since we had already given an initial time increment of this, that's why it has taken a bit more number of frames. 21. Okay, so we are done with the analysis. So let's go to the job. It's completed. Let's go to the results. So this is our column, and let's plot the contours. This is our contour plot. This is our stresses. One mesh is stress. One mesh is stress. This is one mesh is stress in, it's 4.3 MPa. And let me see the deflection. U is the deflection pattern. If you see 0.6, I think it's 0.6, 0.06 mm is the top deflection. If you want to exaggerate the deflection, let's go to options, common, uniform. Oh, it's already exaggerated. Then let's go to the animation, animate how it's a very exaggerated view. Common, uniform, let's exaggerate it by 10 only. That's how, or 100, let's say. That's how it's getting deflected, or deformed rather. Now if I want to see deflection in my reinforcement only, I need to hide this. Let's go to remove. I want to remove part instance, this part. I'll be left with the reinforcement. Done. See how reinforcement is getting deflected. And if I want to visualize my stresses in the reinforcement, here is the stress. Right? It's very, very small stress got developed in this 4.3 MPa only. You can change the loading and other things as well. So the idea, if you can see S11, different stresses, S22 is not there because I have modeled it as a beam. We can go back and you can view the force. What is the force that got developed in my concrete here at the bottom, the reaction force. And I need to sum the total forces at the bottom nodes to get my total reaction, and that should be equivalent to what I had applied just for the equilibrium. And similarly, what if I want to change the background? I've already discussed it. I go to view, I go to the view, go to the graphics option, go to solids. In the solid, I want my background has to be white. Okay. Now my background is white. And this is my reaction forces and all, or the stresses or the deflections and all. And what if you want to play with this? You want to increase the font of this deflection values. You have to go to the viewport, then you have to go to the viewport annotation options. Then if you want to show the, suppose let's go to the legends, select set font. Okay, rather set font. Here is the size. You can increase this size by like 16 mm or 16 units. Here you can increase. I have increased this is just for the, if you want to print or if you want to plot these contours, or you want to use in your Word file, or in your papers or something like that, then this is the option you have to utilize, right? So even you can remove these bounding box of this by unchecking this. Apply, it's been removed. Even title of legion can be removed. You can just mention in the caption. So I believe you'll like this video, and I hope by watching this video you'll be able to get used to different kinds of tools that I have displayed. I have really used here, just like in the assembly, translate, rotate, or creating patterns. That's the copy type option there. And this marks the end of our module, that is module 1 of Abaqus for beginners. So from now on, we'll create module 2, advanced level Abaqus. That is, we'll be using different types of analysis. Uh, we'll be doing static analysis of different components like beams, like frames, by columns. We'll be doing dynamic analysis. We'll be doing both explicit, implicit type of analysis. We'll be creating some complex geometries and then analyzing in now coming videos. I hope by watching this first module, that's Abaqus for beginners, you'll be able to create different types of geometries. You'll be able to use different types of tools that are there in the graphical user interface. And then I hope you'll be ready for some complex analysis, or for creating some complex geometries. Thank you so much for being with me. I hope uh, you'll be there in future as well. Thank you so much.